Hi, I'm Otto Van Geet from the National Renewable Energy Lab. We're NREL in the state of Colorado and the city of Denver in the U.S. And I wanted to talk briefly about our experiences from the Labs 21 program in the U.S., which has been a bit of the inspiration for Peter James and the S-Labs conference that I'm speaking from here. And it's nice to see the UK adopting all these same strategies very aggressively. The strategies that we've learned from Labs 21 is for laboratories, first and foremost, control your ventilation load. That means reducing the ventilation to the lowest safe level, which will be different occupied and unoccupied. So that's the key energy driver because it drives all of the fan energy use and conditioning energy use. So that's first and foremost. There's several ways to do that. But one of the state-of-the-art ways is demand-based ventilation. So looking at the pollutants, if you want to call it that, sampling them in the space, and then using that to set the ventilation rate for the space. It turns out it can be much lower. Typical practices have been 6, 8, 10 air changes. And what we're seeing is that, maybe 4 occupied, 2 unoccupied is more than adequate. And then if you're measuring it real time, you can increase it as needed if pollutants come up. So that's the first strategy. The second strategy is to pay attention to your actual exhaust devices, your fume cabinets, fume hoods, fume cupboards, whatever term you like to use, biological safety cabinets, etc., and make those as efficient as possible. Make them as small as possible and meet your needs first, minimize the number, and then make them as efficient as possible. High performance hoods, etc. So that's the second strategy. The third is pay attention to all your mechanical systems. All the passive systems, make them as big as possible. Pipes and ducts, big pipes and ducts, straight big pipes and ducts are good for low pressure drop design. It turns out that second to conditioning energy, depending on your climate, is fan energy. So if we can first minimize how much we move and then move it as efficiently as possible, that's what we want to do. That means big pipes, straight pipes, and then in the air handlers themselves, making the coils, the filters, etc., fairly large so they have low velocity and low pressure drop. So that'd be the next strategy. The next strategy is trying to be real with the plug loads, the actual energy use of the equipment in the spaces, the microscopes, etc. It's classic, people oversize those. They think it's a bigger load than it's going to be. So they oversize their mechanical systems, their heating and cooling, because they think it's going to be bigger. Better to design for a low number. It's always been a third, a quarter, an eighth of what people design for. So better design for smaller and then modular. So if it turns out to be bigger, then add another pump or another fan or another coil, etc., chiller. So those are the key strategies. And then the last one, and this is very climate dependent, is maybe putting in energy recovery. In our cold climate like where I am, it's important to capture some of the exhaust room temperature air, capture some of that energy and use it to precondition the outdoor air. That's very climate and energy use dependent. In the UK, it may not be as important, but in more extreme climates, it certainly is. And it pays in the UK, but it's not as big as those other hits. So that's the kind of things we've learned from the Labs 21 program, what I've spoken about here at S-Labs, and what I think S-Labs is trying to promote in the UK also. It's been fun to get the UK perspective on these things. All the keynote speakers were talking about integration of labs, integrating different sciences into labs for discovery type things. It's been fun to hear that. It's been fun to be in the sessions and listen and see where people are at energy use wise. And also I'm impressed, I guess, with S-Labs and how quickly it's grown. I've been involved with Labs 21 in the US for 15 years. And it's a much bigger country, and we get maybe 600-700 people. You've done S-Labs for just a few years, and it's already up to about 300 people. So proportionally for your country, it's way bigger than we are. So good job for Peter James.